Okay, so now we have our animated mesh with the growth effect cached, and we're gonna move on to another layer of particle effects. The next layer is gonna be called revolve. So let's create a geometry container, and I'm gonna call this dev revolve. Was the best I could come up with. So let's press C, change color to green, and let's dive inside. First thing we need is exactly the piece of geometry we just cached. So let's get robot density growth. Seems explicit enough. So let's get that. Let's go to the prep robot. Let's get this one. And this is what we have. So it's growing. The intention behind this layer of particle effects is that as the robot is hit by the blast, its surface, the effect of that blast is going to scatter along the surface. So essentially what we want is that at the edge of that growth, we have some particle emission, some things happening. So we don't actually want the whole density area. We just want the edge as it grows. And the way to do that is, again, something of a hack. So I'm gonna use a time shift with an offset of -3 frames. So this is always behind. And what we'll do is with a point wrangle, we're gonna be subtracting to this density the density that's on this one, which is behind. So that will leave us a little piece, a little bit of density growing on the edge. So I don't really know what to call this, but let's just be explicit, subtract density, or isolate edge. Seems like a better name, isolate edge. So F density is going to be equal to F density minus the density from the second input. So 0.1 density at ptnum, and that's it, otnum, ptnum. Let's go to the end, and also as usual, let me kind of expand this. Very important, let's make sure to clamp, so we're not going to go below 0 or beyond 1. Great, so now we have that. No, density, 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 density. All good. So now we only have the edge. Great. Next, we're going to be using that with we'll be getting the same color that we have before. So that's something we keep reusing. So let's go to blast. We have this here somewhere, attribute noise, color gradient, and so these two give us the color that we've been using so far, not that. So now we have some color. Let's just make sure we don't have that compression happening on the that we had on the source, but we're not really interested here. So when we go to the element scale, we want this at 1. Probably bring this down 0.1, maybe even further, 0.08, something like that. Let's go a bit smaller, 0.05. Great. And it's animated. Now let's make sure that the sample is based not on p scale on the point position, but on a rest position, which let me just make sure that our input has. It does. So we have the rest attribute there. So we're not going to be seeing the character sliding through the noise. Great. So we have some color, we have the density animated, and the next thing we're going to do is we're going to set velocity. So let's use a point wrangle for that. And essentially this object already has velocity. If you turn on the trails, you'll see we have trails, and as it goes, so we have the velocity of the deforming mesh. But it would be cool for us to kind of blend that in with. So if you remember, the idea is that the surface is going to be emitting particles, and the best direction for that is usually the normal of the surface. So because we also have normals, or we don't, so let's make sure we have normals. Normal points. So now we do have normals. Yep. And we're going to set V based on a blending between those two. So we have our current velocity based on the geometry deforming, and we have the normals. And we're going to say that the final velocity is going to be equal to a linear interpolation between the current velocity and the normal based on the channel float that we're creating. So let's call this blend so it's explicit, and press the magic button. We have the attribute, and you can see if you want to have a look at this better, you need to kind of just isolate the points. So with an add, you can just isolate the points and see what's happening. Okay, so this is the original velocity trails. Let's go to a frame where it's actually moving. But if we change it to normals, and you'll see, yeah, we have a lot more velocity. So it's the speed of these vectors is much higher. But not only that, but we also have a direction that's more convenient for us, I guess. So I'm going to use this blend, and I'm going to keep it at 0.5. I think it's a good balance. Maybe we should actually emphasize a bit more the normal. So let's keep this at 0.8. Okay. We'll see how this works. We can always scale it down on the pop network as well. So after this, because the particles will be emitted and colliding with the surface, I don't want them to be immediately in contact with the surface, just to be safe that they're not kind of immediately colliding. So I want them to be able to collide eventually, but when they're birthed, when they're emitted, I want them to not collide immediately with the surface. So the best way to ensure that doesn't happen is to apply a peak. And with this peak, I'm just going to offset the surface, the emitting surface, by 0.004. It's more than enough. Okay, so at this point, I'm just going to create a pop network. See how this is working. And on this pop network, let's make sure we go to the initial frame. So that doesn't happen. And yep, everything's okay. Pop network, dive inside. We don't need the merge. We have the source, first input. In this case, we are going to be scattering onto surface. The emission attribute is going to be the density that we just created, okay, that we've been working on so hard. And we're going to scale the point count by area. This is a way for us to control how many points will be emitted based on density. Okay, so if we move forward, we should be able to see something coming up. Okay, and we have some particles being emitted. 0.01 is actually low, so let's kind of make it lower. It's not that many particles. Let's go with 0.004 for now. Okay, what else do we want? Let's go to the dev blast pop network. We can grab the collision here. Control C, Control V, and we have our collisions. And if we were to just simulate with this, wouldn't be very interesting, and there wouldn't be much of a relationship between revolve and the name revolve and the actual simulation. So what was I thinking when I thought of the name revolve? What I thought of was we will be advecting this, so we can come here, pop advect by volumes, Control C, Control V. We could reuse the same advection volume. It's going through the advection volume generation, which is dependent on a solver that's giving us the spline of that little point there, the trajectory of that point. So it needs to go through that, but that's done. This pop advect by volume, I'm not going to be considering the vex expressions. It's just going to be using these. But the thing is that I don't actually just want them to be emitted and immediately follow the advection volume that we currently have. What I want is to create an advection volume that takes into consideration the actual geometry and creates some velocity vectors that revolve around the shapes of our character. Okay, sounds like an interesting thing to do, I bet. And that's what we're going to be working on the next lesson.